Dear listener, today we listen about paradox of an infinite universe, so please listen carefully. Thanks. The paradox of an infinite universe, often referred to as Olbers Paradox, is a contradiction that arises when considering the idea of an infinite and static universe filled with stars, where the night sky should appear infinitely bright due to the light from countless stars reaching our eyes, yet we observe a dark night sky, meaning there must be a flaw in the assumption of a completely uniform distribution of stars across an infinite space. Key points about the paradox. The problem: if the universe is truly infinite and uniformly populated with stars, then no matter where you look, your line of sight should eventually hit a star, making the night sky uniformly bright like the surface of a star. Explanation of the paradox: the darkness of the night sky suggests that the universe cannot be both infinite and static, meaning either the universe is not truly infinite, or it is expanding and the light from distant stars is redshifted beyond our visible spectrum. Possible solutions to the paradox. Expanding universe: the prevailing theory is that the universe is expanding, causing the light from distant stars to be stretched and redshifted, making them too faint to see. Non-uniform distribution of stars: if stars are not evenly distributed throughout the universe, then some lines of sight might not encounter a star. Dust and gas absorption: dust and gas clouds in space can absorb light from distant stars, contributing to the darkness of the night sky. Yeah, Olbers Paradox is a fascinating way to highlight the implications of cosmology. The fact that the night sky is dark was one of the early hints that the universe isn't static and eternal but instead expanding and evolving. The redshifting of light due to cosmic expansion as described by Hubble's law plays a huge role, as does the finite age of the universe, meaning light from the most distant stars simply hasn't had time to reach us yet. Even if the universe were infinite in space, it's finite in time, which prevents an infinite number of stars from lighting up the sky uniformly. The cosmic microwave background radiation (CMB) is actually a leftover glow from the early universe, but it has cooled down to microwave wavelengths, making it invisible to the naked eye. Do you think Olbers Paradox is still relevant today as a thought experiment, or do you see it more as a historical curiosity now that we have a clearer cosmological model? The paradox of an infinite universe, understanding Olbers Paradox. Introduction. The concept of an infinite universe has fascinated scientists and philosophers for centuries. One of the most puzzling questions that arises from this idea is why the night sky is dark. If the universe were truly infinite, static, and filled with an unending number of stars, then every line of sight should eventually reach the surface of a star, making the night sky uniformly bright. This contradiction is known as Olbers Paradox, named after the German astronomer Heinrich Wilhelm Olbers, who formally described the issue in 1823. The paradox challenges our assumptions about the nature of the cosmos and has significant implications for modern cosmology. The problem: a bright night sky in an infinite, unchanging universe filled with stars. Every point in the sky should be illuminated by the light of a distant star. This means that, theoretically, the night sky should be as bright as the surface of the sun. However, our observations contradict this expectation. Most of the night sky remains dark. This discrepancy suggests that at least one of our fundamental assumptions about the universe must be incorrect. Possible explanations and resolutions. Several theories have been proposed over time to resolve Olbers Paradox. Modern cosmology provides a few key explanations. 1. The expanding universe. One of the most widely accepted explanations is that the universe is not static but expanding, as demonstrated by Edwin Hubble's discovery of the redshift of galaxies. As space expands, the wavelength of light from distant stars stretches, shifting it into the infrared or microwave region of the spectrum, making it invisible to the human eye. This redshifting effect causes distant stars to appear dimmer than they otherwise would in a static universe. 2. The finite age of the universe. The universe is believed to have begun with the Big Bang around 13.8 billion years ago. Since light travels at a finite speed, we can only observe light from stars within our observable universe, the region from which light has had time to reach us. This limits the number of stars we can see and prevents the sky from being uniformly bright. 3. Non-uniform star distribution. The universe is not an evenly distributed sea of stars, rather, stars are grouped into galaxies, and galaxies into clusters. Large voids exist between these structures, meaning some lines of sight do not lead directly to a star, reducing the amount of light that reaches us. 4. Absorption by dust and gas. Interstellar dust and gas can absorb and scatter light from distant stars, preventing it from reaching Earth in full intensity. However, over long time scales, this absorbed light would be re-emitted, so this explanation alone cannot fully account for the darkness of the night sky. The cosmic microwave background, a glimpse into the past. One piece of evidence that further supports the resolution of Olbers paradox is the cosmic microwave background radiation CMB. This faint glow, detected in the microwave part of the spectrum, is the leftover radiation from the early universe shortly after the Big Bang. While we cannot see it with the naked eye, it serves as a reminder that the universe was once much hotter and brighter before expanding and cooling to its current state. Conclusion. Olbers paradox, once a profound mystery, has been largely resolved by our modern understanding of cosmology. The expansion of the universe, the finite speed of light, the distribution of stars, and the presence of cosmic background radiation all contribute to explaining why the night sky is dark. The paradox remains an important historical question, as it led to deeper investigations into the nature of space, time, and the evolution of the cosmos. Today, it serves as a fascinating example of how simple observations can lead to profound discoveries about the universe. Please like, share and subscribe my channel for more audiobook and other informative video. Thanks.